Okay, thank you very much. My name is MFOUTOU-MOUKALA. I am from the Faculty of Science and Technology at the University in Congo. I am very glad to present here my contribution, which is entitled A Semantic Data Model of Harmonized Survey on Household Living Standard. First of all, I would like to thank the conference committee for the invitation to present my contribution. And I also want to thank the reviewers of my contribution for their relevant comments, helping improving our contribution. Our contribution is conducted by three people, myself, Mark, and my supervisors, Professor Maker Ngomo and Regis Babindamana. First of all, before diving into the core of our paper, I would like to just present an overview of who I am. Mark MFOUTOU-MOUKALA. I am currently a doctoral student at the Faculty of Science and Technology at Marimba University in Congo. I hold a master's degree in data science and big data at Institut National Polytechnique Félix Houphouët-Boigny of Côte d'Ivoire, which is the National Polytechnic Institute of Ivory Coast in partnership with École Polytechnique, which we also call Ex-Polytechnique Paris. My research domain includes, but not limited to, machine learning, semantic data modeling, knowledge representation, automated reasoning, and also topic modeling. Now, let's move to the core of our contribution. The Harmonized Survey on Household Living Standard is a household survey which is conducted by French-speaking countries in West and Central Africa since the year 2018, aimed at capturing information about the living conditions of households and communities. In order to help public, government, and development partners to try to solve or to identify the areas where solutions can be provided to households and communities. However, during data analysis and data cleaning processes, we noticed that there are some discrepancies between actual collected data and the information, the condition, the constraints which are defined in the methodology documents. We also noticed that when trying to understand the different concepts of the survey, what is the meaning of this question and so forth, we needed, I say we needed because myself, I was involved in the survey in the case of Congo in 2022. So we needed to check manually the methodological documents. So that is a time-consuming task. In our contribution, we aim to solve this issue by proposing a solution which will document the knowledge contained in the methodological documents in order to disseminate this knowledge and also to improve or enhance the quality or the efficiency of the survey. We chose to use what we call resource description framework, okay, and its extension RDF schema. So doing that, it will help improving the efficiency of our survey. Here is a presentation of the main concepts of our survey. We have a class declaration meta model. We have the household member, which is an RDF class. We have the main survey, which is HSHLS, which stands for Harmonized Survey on Household Living Standard, which is defined by section. And in the case of Congo, we have 21 sections. We also have a questionnaire as a class, household as a class, and we will talk about questions as a property further. Here is a presentation of the property declaration meta model. So we have, for example, here belongs to household, which is a property between a household member and a household. That means that a household member belongs to a given household. So The domain here is household member, which defines the subject of our predicate, and the predicate here is our property belongs to, and the object here is the household. We also have other properties like concerns household. Concern household is a property between a questionnaire and a given household. So the domain here, so the subject is the questionnaire. That means that a questionnaire concerns a given household. And we also have other properties. And the main properties here, we have a question describing the characteristic of a given household member. So this is just some actual questions that we collected among all questions we have in our survey. And S02 means the section 2, the second section of our survey, which is the sections and to capture information about the education of the household members. So we have a question like S02Q age, which captures the age of the household member. Here the label is, I translated in French, what is the age of name, like Mark, what is the age of Mark at his last anniversary day, which captures the age of the survey member. We also have a question here, we call it S02Q03 and other questions. And here we notice that there are some dependencies between those questions. And we are going to talk a bit more about those dependencies further. Here we just present the actual constraints of our model because, like we said, we have noticed that there are some discrepancies between actual collected data and the information, the constraint defined in the methodology of our survey. So we need to define, to document these constraints in order when we are going to collect the information to compare this information with the constraints which are defined in our model. So here we have, for example, the constraint reading friend valid rep. That means the valid responses of this question. So we have we for no, no for not. We also have school attendance valid rep, meaning that whether Mark did attend a formal school. Okay, the responses are we for yes or no, Mark didn't attend a formal school. So those are the constraints of our model. Here is our model representing the condition, the dependencies conditions. We have dependencies between questions. We have, for example, the question S02Q01, okay? This question, we have household member as a domain, and we also have some type and also the range. The conditions defined here are that for this question, in order to ask this question S02Q01A, we need to check that the server household member is 9 old or greater. That is a question, a condition defined on that question. So this is just an example. In our comprehensive model, you will find it in the references, the obvious information. Let's talk now about the implementation of our model. We use, like I said, we use RDFs. And here we chose to use the Python RDF lib package to implement our RDF graph. The model we built make it possible to access to our information, the information of our survey, in a persistent way, because we defined what we call an international resource identifier, which can be found through internet, and in the references you will find it. We also use payload in order to implement the web page of our model. And these are the results and discussion. As we said in the introduction, the aim was to build a semantic data model aimed to solve the issues, to help enhance our survey. So the RDF's model has been built, and now, we are going to further to complete the information, because as I said, for only the section S02, we have 21 sections for our survey, and for a given section, we have at least 25 questions for every section. So we are going to implement step by step all these conditions, all these informations. So by specifying the semantic of our questions, we built a model that will help understanding the meaning of the information manipulated in the server, and also it improve the efficiency of our server. So here we are going to just present, okay, we have presented the result. We use the Spark SQL to query the information which are stored in our semantic data model. So when trying to analyze the data, the teams which are committed to analyze the data can use SparkQL to query, to retrieve the information contained in our semantic data model. And also, the large audience of researchers can find relevant information on knowledge representation. Okay. In conclusion, we can say that we have started by building a solution aimed to enhance or improve the quality, the efficiency of our survey, and we will further implement complex constraints in order to capture all information about our survey, and to improve also the quality, data quality of our survey. At last, we are going just to present, we will use in future work, we will use what we call web ontology model, web ontology language, like that we call OWL. Okay? So those are our future work. And at last, we just present our references that we use. In the references, we have the presentation of the HARMONIZED server on household living standard. Okay, you can find it from FAO organization, and we also have the information about our RDF schema, payload, and also the link to the server web ontology model. So thank you very much for your attention, and I look forward to building collaboration with you in my research journey. Thank you.